Hello everybody. Welcome to video notes on naming compounds. But before we really get into naming compounds, I want to make sure everybody understands about the three kinds of bonds. So get these in your notes. I want you to quickly write down, we're going to write down the types of bonds, what those bonds are between, what kind of elements they're between, and what are the electrons doing. So in each kind of bond, electrons are what? So there are three kinds of bonds. We have already talked specifically and in great detail about ionic, covalent, and even though we haven't talked about it, it's very easy to understand, metallic bonds. Those are the three kinds of bonds and the three kinds of ways elements, atoms, are held together. Well, I hope by now you know that an ionic bond is between a metal and a nonmetal. And what ends up happening is an electron leaves the metal, becomes positively charged, goes to a nonmetal, which becomes negatively charged, which then makes both of these ions, which of course is why we call it an ionic bond. Well, what's happening in these kind of bonds is the electrons are being transferred. They're being transferred from the metal to the nonmetal, giving them charges, making them ions. Opposites attract. It's what holds them together. Covalent, which is why we did Lewis dot structures, covalent bonds are always between two nonmetals. And in a covalent bond between two nonmetals, the electrons are shared. We kept talking about how hydrogen has one valence electron, but it wants two to make its outer energy level full, and it does that by sharing electrons with another element, another atom. And then we got metal, nonmetal, two nonmetals. Well, I hope you can see what a metallic bond is between. It is between two metals. And what electrons do here is electrons are swimming around. They are not actually bound to any one element or atom. So you may have several nuclei, but those nuclei can belong to any metal. So that's why you can mix gold and silver and copper and make alloys, because this might be gold, this might be silver. They have their electrons around them, but those electrons are not bound to any one nucleus, so these electrons can go wherever they want. Get them all going in one direction or get them alternating, and that's why metals conduct electricity. But metallic bonds are very simple. Any metals can be mixed together. So, wanted to give you a little background on that, and then I just want to show you this handout. In this handout, history has shown me that kids kind of get confused by this handout. Obviously, we always start right here on this handout. But what I think people have been confused by is, well, I don't know whether to go one way or another. Well, this is simple. You either go, you say yes or no. And based on what you have, you should see what you need to say. This handout is basically it's a flow chart that helps you name simple compounds. Now, they say inorganic because there's a whole other category of naming things that are organic. And we actually can name some of those down here. But organic compounds, that's a whole other story. But if we're going to name something that is ionic, basically if you get down and end and follow through this part of the table that I have circled, that's an ionic compound. You're going to start with a metal, and you're probably going to end with a nonmetal. Well, that nonmetal might also be a polyatomic ion, like we have used many times, and all of our polyatomic ions are listed over here on this chart. Well, we just talked about covalent bonds, and if we are going to name something as a covalent bond or a covalent molecule, we will end up on this part of the table, and that is simply H2, which we could almost delete here because we end up there, and if we have two hydrogens, it's called hydrogen. But the other category, because sometimes you start with an H, and if it's not H2, you have an acid, we do have this entire third category over here, and sometimes the acid will have a polyatomic ion, so it's a little ionic, but sometimes it won't have an ion, it will just be a negative element, a nonmetal, and you go over here. But I'm circling this as a completely different color because this is how we name acids. So keep this in mind as we start using this flow chart, but now the only thing we can really do at this point is just start naming some of these. So if I were to give you this, and we wanted to name it, well, you don't even need this flowchart for that. That is an ion because it has a charge. And what do we call calcium with a charge? It's not a calcium atom, it's a calcium ion. And that would be the name of that. Anything you see with a charge, even these polyatomic ions, you'll notice all these end in the word ion. These are all ions. If you have a charge, you have an ion. So then, let's look at this one. We are going to try to name Li and then big I. So there's an element, there's an element. We always start here. Does this formula start with a hydrogen, H? No. So we go down to this one. Does it begin with a metal that has more than one oxidation number? Is Li on this list of things? The answer is no, it's not. So then we go down here. Does the formula contain a polyatomic ion? Any of the things on this list? Well, if we have ions, it's going to be Li or I, and those are not polyatomic. That's lithium, that's iodine. So the answer is no. Then we go down. Are both of the elements nonmetals? Well, by now you should know lithium is a metal and iodine is a nonmetal. So are they both nonmetals? No. It then says, name the first element, lithium. Then the second element with an IDE ending. So instead of iodine, we are going to have iodide. That formula, that chemical is lithium iodide. And we ended up down here. So now let's look at another one. Let's now look at CUS. If we look at CUS, we start here. Does the formula begin with an H? No. Does it begin with one of these elements that has more than one oxidation number? Another way of thinking about oxidation number is charge. Does copper have more than one charge? And if you look at your passport periodic table, the answer to that is yes. Copper can have more than one charge, but more importantly, with the use of the flowchart, right there's copper. So the answer to this is yes. Name the first element followed by its oxidation number in a Roman numeral. For example, copper 2 or iron 3. So we have to figure out the charge on this copper. There's only one way to do that. What is the charge on sulfur? If you look at a periodic table, or you figure out how many valence electrons sulfur has 6 valence electrons. It would like to have 2 in order to be in this ionic bond. So this sulfur is going to have a -2 charge. The only way that that can then be balanced by making an ionic bond is for that to have a +2 charge. So we want to take the oxidation number, which is +2, but we don't even need the plus because all metals that have a charge are positive to begin with. And what we're going to do is put that in Roman numerals. We're going to call this copper 2. You are going to have to find out the negative charge to figure out the positive charge. So we have now said yes, we've named copper with its Roman numeral. Then we go over here. Does the formula contain a polyatomic ion? The answer is no. Are both the elements nonmetals? No. Name the first element. We already did. We've already named that first element, and it's copper 2. Then the second element with an IDE ending. So instead of sulfur, we don't say sulfuride, we say sulfide. This would be called copper 2 sulfide. Now, if this copper was with, say, something like chlorine, then the chlorine would have a negative 1 charge, the copper would have a positive 1 charge. We would call it copper 1, let's say fluoride or chloride. This seems to be one of the hardest things for students, so we will work several of those problems. Now, let's look at something like this. Let's look at ICl5. This was actually on your quiz for Lewis dot structures. So we're now going to name this thing. If we go through our flowchart, does this formula begin with a hydrogen? No. Does it start with one of those elements that have more than 1 charge? Iodine is not on that list, so no. Does it contain a polyatomic? Well, that's iodine, that's chlorine. Those are not polyatomic. You do not find I over here, and you don't find Cl5 over here. So the answer is no. Are they both nonmetals? Well, is iodine a nonmetal? Yes. Is chlorine a nonmetal? Yes. So then you go over here. Are they the same element? No, they're not. Iodine and chlorine. So now we've made it to this box right here. Name the first element using the proper prefix, but never use mono. Well, we have 1 iodine, and mono is 1, but we don't use mono. So we don't say monoiodine, we just say iodine. Iodine. And then name the second element with the proper prefix, including mono and the IDE ending. So we see on this list that 5 is penta. So we are going to say penta because we have 5 chlorines, but instead of chlorine, we're going to say chloride. This chemical is called iodine pentachloride. And let's just do a couple more. Now let's look and try HF. If we do HF, does this formula start with an H, hydrogen? Well, yes, it does. Are they both the same? No. Then we have an acid. Now we got to learn how to name that acid. Does it contain a polyatomic ion? Well, when it says that, look at everything that's not hydrogen. F. Is F polyatomic? No, it's not. If it was, you would go down this side. But it's not, so we go all the way here. And what we say then is write the prefix hydro. So hydro. Then the second element with the IC ending. So instead of fluorine, we're going to say fluoric. And then add the word acid. This is called hydrofluoric acid, just like HCl is hydrochloric acid. And you may go down this side, and if you have a polyatomic, does it end in ATE or ITE? And then if it's ATE, you replace it with ic. If it is ITE, you replace it with us. Let's do one final problem. Let's now look at KClO3. Now look at this. K is a positive ion. ClO3, those are all nonmetals, but there's a bunch of them. Chances are that's a polyatomic ion, and if you look over here, right there it is. You're going to have to look sideways, but ClO3 with a -1 charge is called chlorate. So if we go through our flow chart, are we starting with an H, hydrogen? No, we're starting with a K. Does that have more than one charge? No. Potassium is always going to have a +1 charge. Well, then we go down. Does it contain a polyatomic ion? The answer is yes, it does. ClO3 is polyatomic. So then we go over here. Is that written first? No. Potassium is. So then we go here. Name the first element. Potassium. Oops. Potassium. And then the polyatomic ion. And we just said ClO3 is chlorate, so this would be called potassium chlorate. We have gone through most of these. Here, if the polyatomic is written first, then you name the polyatomic, then the second element. If there are two polyatomics, you just name both of them. We've gone through and done just about every one of these boxes. There may be a few that we haven't touched on, but I wanted to give you just a little background on using this flow chart and understand why we are. We will please work on the first column of the worksheet, which looks like this. Please do column 1 as much as you can. I'll give you time in class to work on it, but then we'll go over the entire first column tomorrow in class. Thank you very much.